Hello and welcome back. For this video we'll be discussing how to factor perfect square trinomials and differences of squares. A perfect square trinomial, it's a trinomial that results from the square of a binomial. So here we have a binomial, a plus b, and we're going to square it. And that always produces our perfect square trinomial with a predictable pattern. But you'll notice that this is a perfect square here and this is a perfect square here. So we went ahead and put a number in there, 3x plus 2, and we squared it, and we saw that the answer comes out to this. Example 1, how to identify a perfect square trinomial. Two things you can do quickly. Take the square root of the first term. We can see we have a 2x, and that's a perfect square. Take the square root of the last term, and that gives me a 5. Now, if either one of those was not a perfect square, then you're not looking at a perfect square trinomial. Now, to test to see if it truly is a perfect square trinomial, we got to multiply these two together, but then also times it by 2, because remember on the previous page, the middle term comes from 2 times a times b. So this is my a, this is my b term, but then I have to double it. So I have 2x times 5, which is 10, and then 10 times the 2 will give me the will give me 20. Actually, in this case, it gives me positive 20. But remember, 20x. But remember, the pattern is either a plus b squared or a minus b squared. And it's this second one that has the minus here that produces a negative. So as long as I get the number 20, which matches here, I can always match the negative up like I did right here. So that's how you identify a perfect square trinomial. Okay, so how do we actually factor a perfect square trinomial? Now remember, a perfect square trinomial comes from a plus b squared. However, in this case, we have a minus right here as our middle term, so that technically came from an a minus b squared. Alright, so let's go ahead and factor it. So I know I'm going to have an a minus b times an a minus b, which is where the square comes from. Take the square root of this first term, and we have 2x, and it's going to be in the same location, 2x, 2x. Then we take the square root of the last term, and we have a 5 and a 5. And if we were to do the whole FOIL or distribute technique out here, we will see we'll get a negative 10x here to negative 10x here, which combines to make negative 20 up there. So this here ends up being our factored form of the perfect square trinomial, which officially could be rewritten like this over here, which would look like 2x minus 5 squared. But we're going to leave it like this here in the middle, because eventually we're going to let it equal something, probably 0, and then continue solving. Okay, example 3. We see we have a plus here, so we're probably looking at a plus b squared, which again is officially just a plus b times a plus b, which is a plus b squared. Now I want to check to see if I actually have a perfect square. So if I take the square of this first one, square of the last one, I get 3 for the first one times 8 for the last one. And if I double that, it should give me the number here in the middle. So 3 times 8 is 24, and then of course 2 times 24 does give me the 48. So I know I'm looking at a perfect square trinomial. To factor it though, all I got to do is set up my two sets of binomials. I know I'm going to have a plus and a plus because of this middle term here having a plus, so I know they're both positive. Take the square root of 9x squared. The square root of 9x squared is going to give you 3x, and I know I'm going to have 3x in both locations because that's how I get a 9x squared. Then I take the square root of the 64, and I get an 8 and an 8, and I know it's in both locations because that's how I get a 64. And to once again check to make sure I did this right, multiply the middle numbers, that gives me 24 x's. If I multiply the outer numbers, that gives me 24 x's, and when I combine those together, you'll see it matches a positive 48x. So this right here is the factored form. 3x plus 8 times 3x plus 8. Difference of squares. Now, difference of squares is one of our special product patterns, and it only has one pattern. a plus b times a minus b, and it always produces this right here, which is actually the difference of squares. This is really a sum and difference product, or sum and difference multiplication. What it produces is the difference of squares. You'll notice you have a perfect square here, a perfect square here, and a subtraction in the middle. And it's always going to be a binomial. So here's an example. 3x plus 2 times 3x plus 2 is going to give me 3x squared, which is going to be 9x squared. And then 2 times negative 2, which is going to give me the negative 4. And to show that there's no middle term, this right here will give us a positive 6x, and this times this out here will give us a negative 6x, and you can see that those two are going to cancel each other out. That's why there's no middle term here. But the difference of squares always has to have a minus here, with a perfect square there and a perfect square there. If you have a plus in the middle, or either of the two numbers on the outsides are not perfect squares, then you don't have a difference of squares. Okay, how to identify difference of squares? Check this first one. Is that a perfect square? Yes, it's 4x. Is this one a perfect square? Yes, it's 5. Do I have a subtraction in the middle? Yes. So I actually have a difference of squares calculation. Let's go ahead and actually factor. Okay, so to factor, we know we're going to end up with a plus b times a minus b pattern. So in order to get a, we take the square of the first term, so that's going to be 4x. Don't forget you have a plus and a minus. And to get the b term, you take the square root of the second, which is 5 and 5. And there's our answer. We factored it out to 4x plus 5 times 4x minus 5. Example 5, factor a difference of squares. We just want to make sure that we actually have perfect squares. This first one here, 9b squared, is a perfect square. So is this one. And I have a minus in the middle. So difference of squares always factors out into the pattern of a plus b times a minus b. So to find the a value, I simply have to take the square root of the first term, which is going to give me, now the square root of 9b squared is going to be 3b, and I have it in both locations because that's my a value. And to get the b value, take the square root of the second. So square root of 16c squared is going to give me a positive 4c, and then the second one is a minus 4c. And later on we'll eventually put an equals and some value on this side here. And that's how we do difference of squares factoring.